everyone, I hope you're all doing well. On Monday, we started talking about some of the problems with research on college student drinking and a deductive approach to research and what that often looks like in research. We talked about how an example of the deductive approach is starting with a theory and then testing that theory. Today, we're going to be talking about another approach to research that may improve upon some of these issues. First, though, I want to talk about the assignment from Monday and give some feedback to help with your assignment today. Several of you identified the research design as a between-group pre-test post-test. As participants were asked to fill out a survey and then complete the free pour tasks, there was no pre-test. There were different experimental conditions, but no baseline pours were made before participants were exposed to the experimental conditions. Therefore, this would be an example of a post-test only group design. Participants were not randomly assigned to the two groups, but they were randomly assigned to conditions within the groups. While based on the design, there weren't any major threats to internal validity, so I apologize for asking the question on the ICA that was confusing and misleading. The way the authors reported the results make it impossible to know about the individual effects of the intervention. As shown in the graph, only the means were reported, and no individual data points were shown. With results reported like this, we can't see how different conditions affected individuals. Also, as repeated measures within conditions weren't taken, the data may not be representative of individuals' actual behavior. Today we'll be discussing and looking at several papers that may address some of these issues and how results are reported, as well as getting a representative sample of behavior. As always, if you have any questions, please send me an email, but for now, let's go ahead and get started with today's lecture. Researchers and college administrators have suggested that having college students track the number of standard drinks they consume, particularly in a single drinking episode, might be an important skill to help them avoid binge drinking and the associated negative consequences. This may be, at least in part, because college students who report avoiding binge drinking also report counting drinks or setting a drink limit to not exceed a specific number of drinks as two protective strategies they use to avoid binge drinking. However, counting drinks and setting drink limits require some understanding of and an ability to pour a standard serving of alcohol. Please take a minute and pause this video to answer today's poll called Standard Serving Poll under today's Canvas module. When you have finished completing this survey, come back and finish the lecture. Protective strategies, such as counting drinks and setting drink limits, require some understanding of and an ability to pour a standard serving of alcohol. And yet most college students cannot accurately define or pour standard drink servings. Before we can evaluate whether the skill of counting and setting drink limits does reduce the number of negative consequences of drinking, we ought to evaluate whether college students can learn to identify and pour a standard serving of alcohol. Many college students who violate their campus alcohol policies and who are at risk of engaging in excessive drinking are required to take alcohol education courses. Although some university alcohol education courses include a skills training component to help students to recognize and accurately pour a standard serving of alcohol, many do not, even though this tends to be the most effective method for teaching college students to pour standard servings of alcohol. Specifically, students who complete alcohol training courses that include a skills training component are more likely to report decreased alcohol consumption and less likely to report negative consequences related to alcohol consumption compared to students in information-only alcohol training courses. Thus, it seems important to develop and evaluate a skills training component that can be used in university alcohol education courses to teach college students to recognize and pour standard servings of alcohol. Some research suggests that behavioral skills training, BST, a training model comprised of instruction, modeling, rehearsal, and feedback, can be used to teach college students to pour standard servings of alcohol. This relates to what we've been discussing this semester about evidence-based practice. This training method has been tested across different settings to see if it can be useful in teaching college students to pour standard servings of alcohol, with the goal of utilizing this training in alcohol training settings to help college students to accurately count and adhere to drink limits. The dependent measures in the studies we will be discussing are free poured volumes measured in ounces for beer and converted into a percentage deviation from the standard serving. A standard serving of beer is 12 ounces if that beer contains 5% alcohol by volume. For the purposes of these studies that we're going to be discussing, accurate pours of beer were defined as pours within a plus or minus 10% deviation from this standard serving, or pours between 10.8 ounces and 13.2 ounces. This convention has been used by Metz et al., Henkle et al., and Strickland et al., and also we use the same convention in my thesis project. The picture on the screen represents the lines where 13.2 ounces and 10.8 ounces would lie on a standard red Solo cup. Inaccurate pours were those less than 10.8 ounces or those greater than 13.2 ounces. Metz et al. Compared different training methods, all of which have some components of BST, and found that these trainings increased college students' accurate pouring of beer into a round 18-ounce red Solo cup, and that this skill maintained across time for 84% of the participants. Henkle et al. Showed that individual BST was effective in teaching college students to pour standard servings of beer, and that their accurate pouring maintained even in the presence of inaccurately pouring peers. Strickland et al. Examined group BST and showed that BST can be effectively used to teach pairs of college students to pour standard servings of beer. In my thesis study that we're working on now, we extended previous literature showing that BST can be used to teach college students to pour standard servings of beer by seeing if this training will translate to untrained cups that are different from the cup used for training. A participant in Metz et al. Each data point represents a single pour. Pours in the closed circles represent the trained cup, while the open squares represent pours into the untrained cup. Metz et al. Did observe that about 60% of the participants were able to accurately pour into an untrained square 18-ounce red Solo cup. However, no baseline measures of the untrained cup were taken, and the data were comprised of only one free pour per participant per follow-up session, which, as we've been discussing, may not be representative of the participants' overall pouring behavior. This limitation of the study done by Metz et al. Sparked the idea for my thesis study. Based on the data from Metz et al., Henkle et al., and Strickland et al., showing that BST could be used to teach college students to pour accurate standard servings of beer, we saw a gap in the literature and decided to test if training from one cup would lead participants to pour accurately into other untrained cups. For example, if participants are taught to pour accurately into the round cup shown on the screen, would they begin pouring accurately into the square and clear cup without training, or would they need to be trained across each cup in order to pour accurately into each cup? These replications highlight one method of developing research questions. This method, looking at a question of clinical significance and starting with a small question and working our way systematically from smallest to largest, is an example of inductive reasoning. The inductive approach is taking a question and moving from specific to general. This means looking at specific cases first, such as these replications we've been discussing that build on each other in order to build evidence for the use of BST in the context of college student drinking. This is a more conservative way of asking questions than using a deductive approach. This may be testing a phenomenon first, and then developing a theory based on repeated testing. A deductive approach, on the other hand, is starting with the general and moving to the more specific. This may be creating a theory first and then testing it. Researchers using single case designs use an inductive approach when conducting research, in which a phenomenon is first tested and then manipulated repeatedly across a small number of participants. That phenomenon is tested under varying circumstances and populations using systematic replications. These graphs represent data for one group of 3 participants in my thesis study. These graphs may differ slightly from some of the other graphs you will be examining today, but the same general characteristics will show up across all of the graphs. The x-axis represents the free pores within and across phases for a single participant. The y-axis represents the percent deviation from a standard serving of 12 ounces. The gray bar represents accurate pores within a 10% deviation of an accurate standard serving of 12 ounces. Each data point depicts a single free pour of a standard serving of beer. The pores above the gray bar represent overpours, and the pores below the gray bar represent underpours. Phase changes are indicated by a vertical line. Please refer back to this explanation of the graphs in the video to help reading the graphs for your ICA today. Again, feel free to send an email if you have any questions, and I hope you all have a great rest of your week.